solving the problem posed in the question, I'm going to solve one that's similar, and then maybe you can try to work through this one following the same pattern. So we have this function of x where these a, b, and c are constants. So x is the independent variable, and we want to find the derivative with respect to x using the product rule because we have the product of two functions involving x. I like to say, it says state the product rule. I like to say the product rule is the first function times the derivative of the second plus the second function times the derivative of the first. Some textbooks and teachers say that in the opposite order, but here we go. The first function is this. Times the derivative of the second, well, that would be 2c. The derivative of b is 0 because that's a constant, plus the second function times the derivative of the first, which would be 6x squared. Now, if you want to, we can distribute, combine similar terms. So we get 4cx cubed minus 2ac plus 12cx cubed plus 6bx squared. And finally, we can combine these two terms because they are similar terms. So we've got 16cx cubed plus 6bx squared minus 2ac. Now, where's the point on the curve where x is 0? If we want to find f of 0, we'll put 0 in for x, and we get, for this first factor, minus a times 0 in for x, b. So there's an expression that represents the y-coordinate of the point of tangency. So the point of tangency is at 0 minus ab. F prime of 0 will give us the slope of the tangent line at that point. So we put 0 in for x, and we get minus 2ac. So there's everything you need to know to write the equation of the tangent line, a point and its slope. So we'll use point slope. Y minus the y-coordinate of the point of tangency would be y minus a minus ab, or y plus ab, equals the slope, represented by minus 2ac, times x minus the x-coordinate of the point of tangency. Well, that'd just be x minus 0, or x. Finally, if we want to put it in slope-intercept form, minus ab plus, minus 2acx. Or minus 2acx minus ab. Okay, there's your point of tangency. Now, if I share my screen, go to Desmos, there's the original function. That's this red curve right here. If I hide that for a second and show you the derivative, there's what the derivative function looks like, and there's what we came up with on the whiteboard. If I highlight that, you'll see it's identical. So I use the Desmos operator for derivative and my own result, and prove that they're the same. Okay, so there's our graph. The point of tangency is 0, f of 0, or 0 minus ab. They're the same point. And if I change the values of a, b, and c, that'll change the way the original graph looks, but I still get that tangent line at 0. Of course, I can change the values of c and a also. But either way, that proves that this equation right here, y plus ab equals minus 2acx, is the equation of the tangent line at the point where x equals 0. So try the same technique on the original problem and see if you can end up with something good. I will include the link to the Desmos graph so you can maybe experiment there too. There you go.